This is our lesson on absolute value inequalities. It's very similar to one variable inequalities and very similar to absolute value equations. We're just kind of combining the two of them now. So we'll start with this problem here. The absolute value of x plus 5 is less than or equal to 7. And again, we're asking ourselves now, what number is 7 units away from 0? And that could be positive 7 or negative 7. So we write two equations. X plus 5 equals positive 7. X plus 5 equals negative 7. And then we solve each equation. So we subtract 5 from each side. 7 minus 5 is positive 2, so x equals positive 2. Negative 7 minus 5 is negative 12, so x equals negative 12. This time we're going to have two boundary points. When we solved the one variable equation, we only had one boundary point. When we solve an absolute value inequality, we're usually going to have two boundary points. So our boundary points are positive 2 and negative 12, and the circles are going to be filled in. They're going to be closed circles because of the equal to sign in our inequality. Once we have the boundary points labeled, we want to test a point. And I always like to test a point that's in between my boundary points. And 0, if it's in between, is usually the easiest point to test. So if we plug in 0 for x, we have 0 plus 5, that's 5. The absolute value of 5 is 5. So we have 5 is less than or equal to 7. That is true. Since 0 worked, we want to shade where 0 is. But we're not going to go past those boundary points. So we're going to shade in between negative 12 and positive 2. That means now we have our number line done, we need to write our inequality for an answer. And we're going to start with each point on its own. So if we just get rid of the boundary point at 2, we have x is greater than or equal to negative 12. All of the points that are shaded are greater than or equal to negative 12. Then if we get rid of the boundary point at negative 12, we have x is less than or equal to 2. All the shaded points are less than or equal to 2. But there's one other thing we need to add to this, and that's the word and. Because we are greater than or equal to negative 12 and less than or equal to 2. That's what keeps us in between the two of them, is that word and. Because and means it has to satisfy both of these conditions. So only the region in between the 2 points would satisfy both of those conditions. Here we have another one. The absolute value of x minus 3 is greater than 1. So we're asking what number is 1 unit away from 0. That's positive 1 and negative 1. So x minus 3 equals positive 1, x minus 3 equals negative 1. Add 3 to positive 1 and we get x equals 4. Add 3 to negative 1 and we get x equals 2. So those are the two boundary points, positive 2 and positive 4. There's no equal to in our inequality, so the circles are going to be open. This time 0 isn't in between our 2 points, so we're not going to use 0, but 3 is in between 2 and 4, so I'm going to use 3. I'm going to test 3 in the equation, or the inequality. So 3 minus 3 is 0, and the absolute value of 0 is 0. So we have 0 is greater than 1. That is false. So this time when we tested a point in between, it didn't work. Since in between doesn't work, we want to shade to the outside on both sides of our number line. And again, we write two inequalities, one for each boundary point. So for the boundary point on the left, we have x is less than 2. For the boundary point on the right, we have x is greater than 4. And just on as on the last problem, we needed the word and in between. This time we need the word or. Okay? If you're in the middle, you need and. If you're on the outsides, you need or. And that's because we can either be less than 2 or greater than 4. But we can't be both of those at the same time. Less than 2 is over here, greater than 4 is over here. We can't be both of those at the same time, so we need the word or this time. And here's one last example. We have negative 2 times the absolute value of 2x plus 1 is less than negative 2. First thing we want to do is we want to get rid of that negative 2 that's outside the absolute value. So we divide both sides by negative 2. That leaves us with the absolute value of 2x plus 1 equals 1. So we're asking ourselves, what number is 1 unit away from 0? Positive 1 and negative 1. So 2x plus 1 equals positive 1. 2x plus 1 equals negative 1. Subtract 1 from each side, we get 2x equals 1 minus 1, which is 0. Divide by 2, and x equals 0. For the other equation, we subtract 1 from each side. Negative 1 minus 1 is negative 2, so 2x equals negative 2. And then divide by 2, and x equals negative 1. So our boundary points are negative 1 and 0. Again, they're open circles because there's no equal to in the inequality. And then we test a point. If we pick a point in between, this time it's going to have to be a fraction or a decimal. I like to go halfway in between, so halfway in between 0 and negative 1 is negative 1/2. So I plug that into my original inequality. Negative 2 times the absolute value of 2 times negative 1/2 plus 1 is all less than negative 2. 2 times negative 1/2 is negative 1. So I have negative 2 times the absolute value of negative 1 plus 1 is less than negative 2. Negative 1 plus 1 is 0, so I have negative 2 times the absolute value of 0 is less than negative 2. The absolute value of 0 is 0, so I have negative 2 times 0 is less than negative 2. And negative 2 times 0 is 0. So we have 0 is less than negative 2. That is false. We tested a point in between. It didn't work, so we shade to the outside. Now we write an inequality for each boundary point. For the one on the left, we have x is less than negative 1. And for the one on the right, we have x is greater than 0. And again, we need the word or, because we're either less than negative 1 or we're greater than 0, but we can't be both.